Okay, so this is 2023 Physics 115 past exam question, and I'll be explaining in details and bit by bit the answers to all of these questions and how to go about their solutions. So the first question we have here says sub A travels at 8 meters per second, emitting a frequency of 1400 hertz. The speed of sound in the water is 1533 meter per second. So B, being the observer, travels at 9 meters per second in opposite direction. What is the apparent frequency heard by the observer as the subs approach each other? So this is a question on Doppler effects. All right. And for every question on Doppler effects, we have an equation which says the apparent frequency, okay, equals the actual frequency multiplied by the speed of sound plus or minus the speed of observer, okay, all over the speed of sound minus plus the speed of the source. All right. So these are general equation for Doppler effects. Okay. General equation for Doppler effect that's both sound, both the source of sound and the observer moving. All right. So now let's simplify this question. This is question one. Now we're asked to calculate the apparent frequency. They say, what is the apparent frequency? We're looking for this. Did they give us the actual frequency? The question, they say sub A travels at this, emitting at a frequency of this. So this is the actual frequency, 1400 hertz. So we have actual frequency to be 1400 hertz. Okay. The speed of sound in the water, they gave us speed of sound V. V was given to us in the question, and V is equal to 1533 meter per second. This is sub B, being the observer, all right, travels at 9 meter per second. So the speed of the observer was also given in the question. Speed of observer equals 9 meter per second. All right, in opposite direction, they say what is the apparent frequency heard by the observer as the subs approach each other. So the observer and the source, they are moving towards each other. So what's the speed of the source? It was given to us in the question also. This is sub A, being the source, travels at 8 meter per second. So speed of source equals 8 meter per second. All right. So now this is the equation to use, but then do we use plus or we use minus? All right. Now we use plus for the numerator when observer moves towards source, and we use minus when observer moves away from the source. All right. And then for the denominator, we use minus when the source moves towards the observer and plus when the source moves away from the observer. Now in this case, we have observer and source, so we can write it this way: O for observer, S for source. Now they say they approach each other, so observer is moving towards source and source is moving towards observer. They approach each other. So it simply means our equation now is now going to be, for the numerator, we're going to have apparent frequency to be equal to the actual frequency times the speed of sound. All right. Since our observer is moving towards the source, we use plus. So we use plus speed of observer all over speed of sound. Since our source is moving towards observer, we use minus speed of source. So this is the equation we are going to use. All right. So now we simplify it further. And that will give us, if we substitute our values, we're going to have apparent frequency to be equal to the actual frequency is 1400. In brackets, we have the speed of sound, all right, being 1533. As you can see here, we have 1533 plus the speed of observer being 9 all over the speed of sound being 1533 minus the speed of source, which is 8. All right, so we use our calculator and then we simplify the whole of this. We're going to arrive at the apparent frequency to be equal to 1415.61 hertz. All right, so that's the answer to question 1. Now, if you observe, this is just section A. All right, the exam was actually divided into section A and section B. Section A was subjective, and then section B, objective question. So for this one, you just write your answer to the question, which is 1415.61 hertz. Now, question 2 here says a simple harmonic motion having an amplitude A and time t and time period t is represented by the equation y equals, we have our equation to be y equals 5 sine pi, we have t plus 4 meters. You say the values of a in meter and t in seconds are a equals dash and t equals dash. All right, so how do we go about this? First, we can simplify this. We can use pi to open up this bracket. This is 5 sine, please. 5 sine. We can use pi to open up this bracket, and then we're going to have 5 sine. This is pi t plus 4 pi meters. Now, first they say we should calculate amplitude. To get the amplitude, you just compare this with the general equation for a plane progressive wave. All right, and a plane progressive wave, which is also simple harmonic in nature. All right, a simple harmonic motion is simply a motion that repeats itself periodically. So a plane progressive wave is also simple harmonic. That's why we can use a plane progressive wave equation to compare this. And the general equation for a plane progressive wave is y equals a sine 2 pi ft plus 2 pi x over lambda meter. All right, so now first the amplitude. How do we get the amplitude? You simply look at what you have here. This is 5 sine. All right, what do you have at the back of sine? 5. All right, and what do you have at the back of sine here? A. So if we compare this with this, you see that the amplitude in this equation is 5. All right, whatever is at the back of sine is the amplitude. So we simply use sine as our landmark for locating the position of the amplitude. So in this case here, for this equation, amplitude is equal to 5. So A is 5 meter. And then for the frequency, we use small letter t as our landmark, just like we use sine for landmark of amplitude. Anything at the back of sine is amplitude, so 5 is going to be our amplitude here. So now for the frequency, we simply use small letter t as our landmark. So we equate the whole of this, all right, with the whole of this to get frequency. So in that case, we are going to say 2 pi ft equals pi t. Small letter t will cancel small letter t, pi will cancel pi, and you will be left with 1 here. So now you're going to have 2f rather, all right? T has already cancelled out. We'll be left with 2f equals 1. So f will be equal to 1 over 2. So this is the frequency. But what we need is period, all right? They said we should get the amplitude in meter and the period in seconds, capital letter T. Now, recall, period is equal to 1 over frequency. So if frequency is 1 over 2, we simply take the inverse of this and then we're going to get period. So it simply means period will be equal to 2 seconds. So our answer to this question is 5 meter and 2 seconds. 5 meter and 2 seconds. All right. 5 meter for the amplitude and then 2 seconds for the period. Now the next question, question 3, it says the temperature at which the speed of sound doubles as was at 27 degrees Celsius is the temperature at which the speed of sound doubles. All right, so we're looking for the temperature at which speed of sound will double as was at 27 degrees Celsius. So 27 degrees Celsius is like our initial temperature. So we have theta 1 equals 27 degrees Celsius. And then Theta 2 is the new temperature we're looking for. Now remember, at theta 2, the speed of sound doubles. That's to say, it will be double of the initial speed. So if the initial speed is v, the new speed will be equal to 2v. Now to solve this, we simply use the relationship between the speed of sound and temperature. And mathematically, that is equal to v1 over v2 equals square root of theta 1 over square root of theta 2. Now v1 is v, so we're going to have v all over v2 is 2v equals square root of theta 1. Now please always ensure you convert your temperature to Kelvin. From 27 degrees Celsius, you can convert this to Kelvin. How do we convert? We simply add 273 and it becomes 300. So we have square root of 300 all over square root of theta 2. Alright, so v will cancel v here and you're going to have 1 over 2 equals, this is simply all square root of 300 all over the new temperature which we're looking for. Now to get the new temperature, we'll take square of both sides. So we're going to have 1 over 2 all squared equals square root of 300 all over theta 2 all squared. Alright, so this is going to cancel out this and you're going to have 300 all over the new temperature equals 1 squared is 1 all over 2 squared is 4. So we have 1 over 4. Alright, so to get the new temperature now, we simply cross multiply. So we're going to have theta 2 times 1, that will give us theta 2 equals 300 times 4, that will give us 1200 Kelvin. Remember, we converted this to Kelvin, to 7 degrees Celsius to Kelvin, we added 273. Alright, so that gave us 300. So it simply means your new temperature here will also be in Kelvin. Now number 4, question 4. They said, what is the sound level that corresponds to an intensity of 2 times 10 raised to the power of minus 7 watts per meter squared? Now you need to understand that sound level in decibel is giving us L equals 10 log I all over I naught. This is the equation for sound level in decibel. Alright, L is the sound level in decibel. 10 is a constant, 10 log is a constant. I is our intensity of sound, and then I naught is the threshold of hearing. Alright, is a constant and is always equal to, I naught is always equal to 1 times 10 raised to the power of minus 12 watts per meter squared. Watt per meter squared is the unit for intensity. Alright, so now they gave us the intensity of sound in this question. They said, what is the sound level that corresponds to the intensity of this? So the intensity of sound was given to us in the question to be 2 times 10 raised to the power of minus 7 watts per meter squared. Alright, so to solve this, we just plug in our values into this equation and then we get our answer. So we have L to be equal to 10 log, we have I, which is 2 times 10 raised to the power of minus 7 all over I naught, which is 1 times 10 raised to the power of minus 12. And that will give us intensity level to be equal to, if we simplify this, we're going to have arrive at approximately 53. Alright, so we have 53 decibel as our answer. Now question 5 rather, it says heat was supplied at the rate of, alright, we have joules per second, that's work done over time. So this is power. Alright, so they gave us the power here. Heat was supplied at this rate, 50 joules per second. So we have power to be 50 joules per second for 1 hour 40 minutes to a block. So they gave us the time taken to be 1 hour 40 minutes. Okay, so they say what quantity of heat absorbed by the metal, alright, or was absorbed by the metal, assuming there was no heat loss to the surrounding. So we are looking for the quantity of heat energy. Alright, So now, what's the relationship between quantity of heat energy or energy with power? We know that power is equal to heat energy or energy all over time. So to get Q, we simply say Q will be equal to power times time. All right. So now, what is the power in this question? Power was given to us to be 50 joules per second. Time is 1 hour 40 minutes. We need to convert time to seconds. All right, because we have power here in seconds. So we have time being 1 hour 40 minutes. All right, to seconds. 1 hour to seconds. 1 hour is equivalent to 3,600 seconds. All right, it's a constant. And then for 40 minutes, 1 hour 40 minutes is like saying 1 hour plus 40 minutes. So here we're going to have 3,600 seconds plus 40 minutes. 40 minutes to seconds will be 40 times 60. So that will give us time to be equal to 3,600 plus we have 40 times 60. That will give us 2,400. Adding this up, we're going to have time to be equal to 6,000 seconds. So now we can come back to our equation, which is quantity of heat energy being power times time. Power is equal to 50 times time, which is 6,000. And that will give us the quantity of heat energy to be, we have 50 times 6,000, which is 3 times 10 raised to the power 5 joules. So this is our answer for question 5. Now moving on, we have question 6. It says the electrical resistance recorded by a thermometer at triple point of water is 120 ohms. So we have resistance, this is question 6. Resistance at triple point of water to be 120 ohms. They said, what is the Kelvin temperature of the medium? What is the Kelvin temperature of the medium in which the resistance increases by 30 ohms? In which the resistance increases by 30 ohms. So we are looking for the temperature in which this resistance now will increase by 30 ohms. So we have a new resistance at this temperature, and that new resistance will increase by 30 ohms of this initial resistance. All right, so our new resistance is going to be, since it's increasing by 30 ohms, we are going to add 30 to 120 and it becomes 150 ohms. Now to calculate the Kelvin temperature, we're going to make use of the equation T equals 273.16 RT all over RTRI. Alright, where this is the resistance at the unknown temperature and this is the resistance at triple point of water. Alright, so we plug in our values and then we're going to have the unknown temperature to be equal to 273.16 times resistance at unknown temperature, which is 150, all over resistance at triple point of water, which is 120. Right, so this is the equation for calculating the Kelvin temperature. So we have T equals 273.16 times 150 divided by 120, and this is going to give us 341.45 Kelvin is our answer. So this is the equation we use anytime we are talking about triple points of water or the thermodynamic temperature scale or the Kelvin scale. Now moving on, we have question 7. Question 7 here says, write the mathematical equation to represent the first law of thermodynamics and define the symbols used. Now the mathematical equation to represent the first law of thermodynamics is given us, we have delta U equals Q minus W. Alright, where delta U here is the change in internal energy of the system. Alright, this is change in internal energy of the system, and then Q is the heat gained by the system, and then W is the work done by the system on the surrounding. All right, please take note of what each term here represents. Q is delta U is the change in internal energy of the system. Q is the heat gained by the system, W is the work done by the system on the surrounding. Now moving on, we have question 8. It says the image defect of having different colored images when white light is incident on a lens is, this is known as chromatic aberration. All right, chromatic aberration. Chromatic aberration is the image defect of having different colored images when white light is incident on a lens. All right, and this usually occurs because a lens has different refractive indices for different wavelengths or colors of light. All right, so each color focuses at different points. Now question 9, we have total internal reflection occurs when light passes from. Now, total internal reflection will only occur when light passes from an optically denser medium to an optically less dense medium. So an optically less dense medium. All right, and then question 10, it says the minimum distance between an object and its image in a convex lens is, it is given as 4 times the focal length. This is the minimum distance. All right, f is the focal length. All right, so 4 times the focal length, or 4f, is the minimum distance between an object and its image in a convex lens. Now question 11, which is section B now, the objective part. All right, it says a point source emits sound waves with an average power output of 80 watts. A point source emits sound waves with an average power output of 80 watts. So we have power given to us is question 11. Question 11. Power given to us to be 80 watts. They say find the intensity 3 meters from the source. So they gave us the distance to be 3 meters from the source. All right. Now the intensity of sound, all right, assuming it radiates uniformly in all directions, is given as I equals P all over 4 pi r squared. This is the relationship between intensity of sound, power, and the distance. All right. I is the intensity of sound, all right, and P is the power, all right. R is the distance from the source. All right, the whole of this is also known as the inverse square law. All right, so now looking at what we were given, we want to calculate the intensity of sound. We were given power, and then we were given the distance. So we can just plug in our values and we'll get our answer. So we're going to have intensity to be equal to the power, which is 80 all over 4 pi, times the distance, which is 3 squared, r squared. All right, and if we simplify this, we're going to have our intensity. Simplifying this equation, the whole of this, we're going to have intensity to be equal to 0.707 watts per meter squared, which is option C. So option C is the correct answer for this question. Now question 12, we have that which of the following expressions does not represent simple harmonic motion? All right, so we have option A cos omega t, option B, A sine 2 omega t, option C, A sine omega t plus B cos omega t, and option D, A sine square omega t. Now option D is the odd one. It is odd because of this square there. All right, our displacement is usually not squared. All right, so option D is the odd one. That is the one that does not represent a simple harmonic motion. Now question 13. All right, so question 12 answer is option D. Question 13, they said in a stationary wave, option A, they said strain is maximum at antinodes. Option B, strain is maximum at nodes. Option C, strain is minimum at nodes. Option D, strain is constant throughout. The correct answer is option B. Alright, option B is the correct answer. Strain is always maximum at nodes. Alright, so take note of it. Strain is maximum at nodes. And also, you can even look at the options. You see that one of them has to be the correct answer. And yet they've given you strain is maximum at antinode, strain is maximum at node. So one of these must be the answer. All right, these two are just opposite of each other, so you cannot have two contradicting things in one question. All right, so one of them has to be the answer, and the correct answer is option B. Question 14, they say an open pipe of length 33 cm resonates to a frequency of 1000 hertz. It is A, they say fundamental frequency of pipe, B, first harmonic of pipe, C, second harmonic of pipe, and then D, fourth harmonic of pipe. So how do we go about this question? It is very, very easy. Now, we need to understand that they said open pipe length at 3 cm resonates to a frequency of this. Alright, so this frequency, could it be the fundamental frequency or the first harmonic or second harmonic or fourth harmonic, as the case may be? That's what you're asked to look for. Now, first, we need to understand that fundamental frequency of an open pipe is given as V over 2L. Alright, V was not given to us in this question, but V is the speed of sound, and we can take it to be 330. So we can have that fundamental frequency will be equal to 330 all over 2L. L is the length of the pipe. Alright, 330 is a meter per second. Alright, the speed of sound. So this length here, we have it to be 33 cm, is in cm. We need to convert it to meter. And to convert cm to meter, we divide 33 by 100. So we have 33 divided by 100, and that will give us 0.33. So we're going to have 330 divided by 2 times 0.33. So that will give us fundamental frequency to be 330 divided by 2 times 0.33, which is going to give us 500 hertz. So it simply means the fundamental frequency, all right, of this pipe of length 3 cm is 500 hertz. All right, now they are asking us, they said it resonates to a frequency of 1000 hertz. Now this 1000 hertz, what does it represent? Is it fundamental frequency? No, it cannot be fundamental frequency, because fundamental frequency is 500 hertz. All right, now they're also asking you, is it first harmonic, is it second harmonic, or is it fourth harmonic? Now this is fundamental frequency, and fundamental frequency is the same thing as a first harmonic. All right, because harmonics are whole number multiples of fundamental frequency. That's positive whole numbers. All right, for an open pipe, they are all positive whole numbers. So first harmonic, all right, first harmonic will be equal to 1 times fundamental frequency, which is fundamental frequency. Second harmonic will be 2 times fundamental frequency, all right, which is now going to be 2f0. So if f0 is 500, second harmonic will be 2 times 500, which is 1000 hertz. So it simply means this 1000 hertz in this question represents the second harmonic. We don't need to solve further. If we want to get third harmonic, we still say 3f0 and so on and so forth. So our correct answer for this question here is option C. Now we also have something that looks like question 15 here, but it is not very clear. And this one says column has resonant frequency 100 Hz, 300 Hz, 500. It's supposed to be 500 Hz. Then it's supposed to be maybe an air column has its resonant frequencies of this. All right. So they said it may be a pipe closed at both ends. There's no pipe that's closed at both ends. All right. The next one, they say a pipe closed at one end. A pipe closed at one end is a closed pipe, and this is supposed most likely the correct answer, option C. A pipe closed at one end is a closed pipe. How did I know it's a closed pipe? We have frequencies of 100, 300, 500 hertz. So this is like our fundamental frequency f0. And for a closed pipe, we have that the harmonics, all right, are odd whole number multiples of fundamental frequency. This is first harmonic, second harmonic, third harmonic. All right. So for closed pipes, we are going to be working with odd whole numbers. That is 1, 3, 5, 7, and so on and so forth. All right, so for this one, we're going to have 1 times fundamental frequency, which is the first harmonic will be 1 times fundamental frequency, which is 1 times 100, that's 100. Second harmonic will be 3 times fundamental frequency, which is 3 times 100, 300. And then the third harmonic will be 5 times fundamental frequency, 5 times 100, which is 500 hertz. All right, so this is for a closed pipe, and the closed pipe is a pipe that is closed at one end. So this is option C. It's most likely going to be option C, though the question is incomplete, but from what we can see here, option C is most likely the correct answer. Now, question 16, they say in a closed organ pipe, first resonance occur at 50 cm. Now, we need to understand that a closed pipe usually starts with a node and ends with an antinode. So we have node and antinode. All right, where L is the length of the pipe, so we have length of the pipe given. This is question 16. Length of the pipe given. All right, and then from node to antinode, we know it is lambda over 4. All right, so this is the first resonance, the fundamental mode of vibration that gives the first resonance. And from here, we see that our length of pipe is 50 cm. So we're going to have lambda over 4 to be equal to 50. All right, so to get lambda, we simply cross multiply this 50 over 1. We have lambda times 1, so we have lambda equals 200 cm. All right, so they said at what length of pipe will the second resonance occur? Now the second resonance, okay, will also start with node and end with its antinode, but it's going to have 2 loops. So we're going to have something like this: node, all right, this is first resonance, and this is going to be second resonance. So we have node, antinode, node, and antinode. All right, now the distance between a node and a node is lambda over 2. Node to antinode is lambda over 4. If we combine these together, we're going to have the total length to be 3 lambda over 4. So we are looking for the length L, the value of L. So from what we see here, we see that L is equal to 3 lambda over 4. And remember, we've already calculated the wavelength to be 200. The wavelength will be constant for the two of them. So we're going to have L equals 3 times 200, all right, all over 4. And that will give us L to be 3 times 200 over 4. And that will give us 150 cm, which is option A. Now moving on, we have question 17. It says, with a closed end organ pipe of length L, the fundamental tone has a frequency of. Now, the fundamental frequency of a closed pipe is always V over 4L. All right, fundamental frequency for a closed pipe is given as F naught equals V over 4L. All right, so which one of them has V over 4L there? Okay, option B says V over 4L and all harmonics are present. No, for a closed pipe, all harmonics are not present. We only have positive odd whole numbers. All right, positive odd whole numbers. So just odd numbers are used. Now option C says V over 4L. Yes, that's the fundamental frequency. All right, and only odd harmonics are present. Yes, this is option C. So question 17, correct answer is option C. Now question 18, it said the velocity of sound in any gas depends on. Velocity of sound in any gas depends on. We have wavelength of sound only, density and elasticity of gas. Option C, intensity of sound waves only. Option D, amplitude and frequency of sound. Now, the velocity of sound depends on the medium. All right, depends on the medium, not on the wavelength of the sound, not on the amplitude and frequency of the sound, not on the intensity of the sound. So the correct answer is option B, which is the medium, talks about the medium, density and elasticity of the gas. All right. So option 18, question 18, our correct answer is option B. Now, question 19, they said, which of the following is not a characteristics of sound wave? Which of the following is not a characteristics of sound wave? We have velocity, we have viscosity, we have amplitude, we have wavelength. Velocity is a characteristic of sound wave. Amplitude also, wavelength also. Viscosity is a characteristics of the medium. All right. So the correct answer is option B. It is not a characteristics of sound wave. Now, question 20, they say the correct range of temperature measurement using the thermocouple is. Now, a thermocouple actually measures a very wide range of temperature. All right. So the correct answer is actually option B. Okay. Thermocouple usually measures from, they say the correct range of temperature measurement using thermocouple is, the correct range is actually minus 200 degrees Celsius to 1200 degrees Celsius. Thermocouple usually measures a wide range of temperature. Now, question 21, they said determine the thermodynamic temperature at the pressure of 850 millimeter mercury and triple point of water of 760 millimeter mercury. So again, another question on thermodynamic temperature T. All right, we're looking for thermodynamic temperature. Okay, they say determine the thermodynamic temperature at the pressure. So pressure at thermodynamic temperature. So PT is equal to 850 millimeter mercury and triple point of water pressure. Pressure at triple point of water is equal to 760 millimeter mercury. Millimeter mercury. All right, so we're looking for T. Now our equation is T equals 273.16 pressure at unknown temperature all over pressure at triple point of water. All right, and that will give us the unknown temperature to be equal to 273.16. Pressure at unknown temperature is 850, so we have times 850 all over pressure at triple point of water is 760, so we have all over 760, and that will give us the unknown temperature to be equal to, we have 273.16 times 850, all right, all over, we have 273.16 times 850 all over 760, and that will give us 305.51 Kelvin, which is option A. Now, question 22 here says, this is question 21. Now, question 22 says, a temperature value of 122 degrees Fahrenheit is equivalent to, a temperature value of 122 degrees Fahrenheit is equivalent to, now to convert from degrees Fahrenheit to Celsius, because all our options here are in Celsius, so basically they're asking us to convert it to Celsius. To convert from Celsius to degrees Fahrenheit, we use this equation. Degrees Celsius is equal to 5 over 9 degrees Fahrenheit minus 32. All right, so our answer in Celsius now will be equal to 5 over 9 times degrees Fahrenheit. We are looking for 122 degrees Fahrenheit in Celsius. So we have 122 minus 32. Okay, and that will give us degrees Celsius to be equal to, if we simplify the whole of this with our calculator, we're going to have 50. So our answer, 122 degrees Celsius, sorry, 122 degrees Fahrenheit is equal to 50 degrees Celsius. That's your answer. Now, question 23. For question 23, it says, given that the length of mercury thread of liquid in glass thermometer at ice point and steam point are 3 cm and 23 cm respectively. So length at ice point, we usually represent it with L0, and length at steam point with L100. So the length at ice point, they say, is 3 cm, all right? Length at steam point is 23 cm respectively. That's, we take them one accordingly. All right, so this is what we have. Now they said determine the temperature reading when the length is 18 cm. So we are looking for the temperature. All right, the temperature, unknown temperature, when the length at unknown temperature is 18 cm. So what's the equation that relates this? This is actually on that Celsius scale, all right? So what's the equation that relates this? We know that unknown temperature over 100, this is the equation for it. Unknown temperature over 100 equals length at unknown temperature minus length at ice point or 0 degrees Celsius all over length at steam point or 100 degrees Celsius minus length at ice point. So we're looking for unknown temperature. We say unknown temperature over 100. Plug in your values for length at unknown temperature, which is 18, minus length at ice point, which is 3, all over length at 100 degrees Celsius, which is 23, minus length at ice point, which is 3. All right, so that will give us unknown temperature over 100 equals 18 minus 3, which is 15, all over 23 minus 3, which is 20. So now we cross multiply 20 times the unknown temperature. We have 20 theta equals 100 times 15. 100 times 15. So to get the unknown temperature, we'll divide both sides by 20. So that will give us unknown temperature to be 100 times 15 all over 20. And that will give us our unknown temperature to be, we have 100 times 15 all over 20. And that will give us 75 degrees Celsius. All right, Celsius scale formula will always give us answer in Celsius. Now, if we look at our options, everything here is in Kelvin. All right, so we need to convert our answer from Celsius to Kelvin. So how do we convert from Celsius to Kelvin? We simply convert by adding 273. Okay, so for question 23, our final answer in Kelvin will now be 273 plus 75. And that will give us the unknown temperature to be, it should give us 273 plus 75. That will give us 348 Kelvin. 348 Kelvin, which is option C. Now question 24. It says calculate the root mean square velocity of a gas of molar mass. So they gave us molar mass of gas to be 500 grams per mole. They say at a temperature of 300 Kelvin. So we have temperature to be 300 Kelvin. Given that the ideal gas constant being R equals 8.31 joules per mole per Kelvin. Alright, so to solve this, we simply make reference to our equation for the root mean square velocity of gas, which is giving us V root mean squared equals square root of 3 times ideal gas constant times the temperature all over the molar mass. All right, so if we plug in our values, we're going to have the root mean squared velocity to be equal to square root of 3 times ideal gas constant is 8.31 all over, sorry, ideal gas constant is 8.31, so we have 3 times R times the unknown temperature, which is 300, so we have times 300. All right, is all square root. So it's all over the molar mass. The molar mass is in gram per mole. We need to convert it to kilogram per mole. All right, kilogram per mole, because everything here is in their standard unit. So 500 gram per mole to kilogram per mole, we divide by 1000 to convert. So we have 500 divided by 1000. This is going to give us 0.5 kilogram per mole. All right, so this is 0.5 kilogram per mole. That's what we're going to use to solve. So we have all over 0.5. All right, so if we now use our calculator to simplify this, we're going to have the root mean square velocity to be equal to, we have all we have 3 times 8.31 multiplied by 300 divided by 0.5. Okay, and that will give us 122.30 meter per second. All right, that is approximately 122.3, which is option A. Now, question number 25. Question 25. It says the quantity of heat in a body of mass, they gave us mass to be 800 grams, and specific heat capacity, they gave us specific capacity to be 150 joules per kilogram per Kelvin. When heated from a temperature of, they give us initial temperature to be 30 degrees Celsius. Okay. To a new temperature, they give us final temperature to be 120 degrees Celsius. Okay. We're looking for the quantity of heat energy, and mathematically we have quantity of heat energy equals mc delta theta. This is the equation for calculating quantity of heat energy. All right, it's the formula we use in calculating quantity of heat energy. Now, please, your mass has to be in kilograms before you use this formula. Now, they gave us this guy in grams, so to convert from grams to kilogram, we divide by 1000. So we're going to have 800 divided by 1000, and this is going to be equal to 800 divided by 1000. That will give us 0.8 kilograms. 0.8 kilograms. All right, so now we can plug in our values. We're going to have quantity of heat energy equals the mass, which is 0.8, times specific heat capacity, which is 150. All right, times the temperature change, which is 120 minus 30. All right, and this is 90 degrees Celsius. So we have times 90. That will give us quantity of heat energy to be equal to 0.8 times 150 times 90, and that will give us 10,800 joules. So that's it for question number 25. Now, question 26 says, which of the following makes use of radiant energy as a thermometric substance? We have thermocouple, optical pyrometer, clinical thermometer, and the gas thermometer. Now, the optical pyrometer actually measures temperature by comparing thermal radiations from a hot object to a calibrated source. Alright, so our correct answer is the optical pyrometer. Alright, it's the one that makes use of radiant energy as a thermometric substance. Now, question 27 says, which of the following methods of heat transfer require material medium? Alright, material medium. Both conduction and convection actually require material medium. The only one that does not require material medium is radiation. Alright, conduction and convection require a material medium. So option A says conduction. Alright, not just conduction, we have conduction and convection. Option B says conduction and radiation. No, radiation does not require material medium. Option C is the correct answer. Conduction and convection, alright, require a material medium. And then question number 28, it says, if light rays intersect a plane mirror at an angle of 25 degrees from the vertical to the surface, find the angle between the incident ray and reflected ray. Let's try to sketch this diagram together. We have our mirror, plane mirror, and then we have normal to the surface. We can call it N. We have light ray being incident on this at an angle. Then we have the reflected ray. So we have incident ray, reflected ray. Now the question is said, if light rays intersect a plane mirror at an angle of 25 degrees, intersect, alright, or hits the plane mirror at an angle of 25 degrees from the vertical. So this is the vertical, normal to the surface. we have 25 degrees to the vertical. They said, find the angle between the incident ray and reflected ray. So we are looking for this angle. All right, so how do we get it? We already know this angle to be 25. If we can get this, then we can say the sum of everything here, okay, is going to give us the angle from incident ray to reflected ray. Now, according to our laws of reflection, we have that the angle of incidence is always equal to the angle of reflection. So if angle of incidence is 25 degrees, angle of reflection will also be 25 degrees. All right, so the angle between incident ray and reflected ray will be equal to 25 plus 25, which is 50 degrees. And that should be option B. Now, question 29 here says an object 3 cm high. Question number 29. All right, an object 3 cm high, we have height of object to be 3 cm, is placed 16 cm in front of a converging mirror. All right, so we have object distance. Okay, the object is placed 16 cm in front of a converging mirror. So we have object distance to be 16 cm. So that it produces an image 40 cm from the mirror, we have image distance to be 40 cm. They say find the height of the image. All right, you're looking for height of image. Now these two are related by the magnification formula. The same thing with height of image and height of object. We have that magnification is equal to height of image over height of object. And magnification is also equal to image distance over object distance. So we can just use this equation and solve to get our answer. So we're going to have height of image being unknown. That's what we're asked to look for. All over height of object being 3 equals image distance being 40 over object distance being 16. If we cross multiply, we're going to have height of image times 16. That will give us 16 times height of image equals 3 times 40. So to get the height of image, we divide both sides by 16, and that will give us 16 HI all over 16 equals 3 times 40 all over 16. So this will cancel this, and then you're going to have height of image to be equal to, if we simplify this with our calculator, we're going to have 3 times 40, okay, divided by 16, and that will give us 7.5 cm, which is option C. Now moving on, question 30. Question 30 here says, a man stands 50 cm from a concave mirror. So the man is the object from the mirror. So we have object distance to be 50 cm. With radius of curvature 10 cm, you have radius of curvature of the mirror to be 10 cm. They say find the position of the image and magnification. So we are looking for image distance and then also the magnification. To solve this, we'll make reference to our mirror equation, which is 1 over f equals 1 over u plus 1 over v. F is the focal length. They gave you radius of curvature. To get the focal length, you divide radius of curvature by 2. All right. So focal length, can write it down here. Focal length is half radius of curvature. So focal length will be 5 cm. All right. So before we solve, we're going to ask ourselves, is this a concave mirror or convex mirror? All right. It's a concave mirror, and concave mirror usually have focal length to be positive. Had it been just a convex mirror, we would have had our focal length to be negative. So it's important we now put the negative sign here, right? But this is not a convex mirror, so we don't attach any negative sign. We'll leave it this way. So we'll come down here, we'll say 1 over focal length being 5 equals 1 over the object distance, which is 50, plus 1 over the image distance. So to get the image distance, we move this guy over to this side, and then we're going to be left with just 1 over v on this other side. So we have 1 over v now equals 1 over 5 minus 1 over 50. And that will give us 1 over the image distance to be equal to, we have 1 over 5 minus 1 over 50. All right, and this is going to give us 9 over 50. 9 over 50. But what we need here is v, not 1 over v. So to get v, we take inverse of both sides. We have v over 1 equals 50 over 9. All right, if we simplify, we are going to have 50 over 9. 50 over 9 equals 5 points. We have 5.56. All right, everything is in cm, so we have cm here. All right, so that's the image distance. Now for the magnification is equal to image distance over object distance. So we have m equals v is 5.56 all over object distance, which is 50. All right, so we're going to have 5.56 divided by 50, and that will give us magnification to be 0.11. Magnification does not have any unit, so that's the answer. So our answer is image distance 5.56 cm, object distance 0.11, and that is option A. Now question 31 here says the critical angle at an air-liquid interface is 50. So we have C being critical angle to be 50 degrees. So calculate the refractive index. Now refractive index is simply equal to 1 over sine of critical angle. All right, so we are going to have 1 over sine 50, and that will give us 1.31 approximately. All right, refractive index 2 does not have any unit, so we have option C. All right, so that's question 31. Now question 32 says refractive index of a material depends on the dash of light. All right, refractive index of a material depends on the dash of light. Okay, now refractive index depends on wavelength or color of light. All right, so the wavelength usually goes alongside the color of the light. All right, and this is the reason why white light will split into colors in a prism. Okay, so refractive index depends on the color, option A. Now question 33, 32 is option A. Question 33, they said when considering the spectrum of white light, the most and least deviated rays are dash and dash. Now, one way of knowing this thing is to just use this acronym ROY-BIV. ROY-BIV. All right. This gives us the different colors we are going to have in the spectrum of white light. R here stands for red, O stands for orange, Y stands for yellow, G stands for green, B stands for blue, I stands for indigo, and V stands for violet. All right. Now, in the arrangement, this arrangement actually gives us increasing deviation. All right. This is actually an increasing deviation. Arrangement in increasing deviation. Red, orange, yellow, green, blue, indigo, and violet. So it simply means violet is the most deviated. We have increasing deviation. Violet will be the most deviated, and red will be the least deviated. So now they said the most and least deviated rays are dash and dash respectively. So most is violet, least is red. So our answer is supposed to be violet and red, which is option B. Now question 34 says minimum deviation is obtained when ray passes. All right, now deviation is minimum when light ray passes symmetrically through a prism. All right, deviation is minimum when rays of light pass symmetrically through a prism, and at that point we have that our angle of incidence, all right, is equal to the angle of emergence. All right, so the correct answer is option B, symmetrically through a prism. And question number 35 now. Question 35, it says a converging lens formed an image which is erect and magnified 4 times. All right, we have magnification to be 4. It says calculate the object distance. We're looking for u if the focal length is 20 cm. So from this, we have that, or we can recall from magnification formula that magnification is equal to V over U. So if magnification is 4, we have 4 equals V over U. V will be equal to 4U if we make V subject of the formula. Now, if we want to use our equation, we are looking for, they said calculate the object distance. If we are looking for U, we need to make reference to our equation of length, which is 1 over F equals 1 over U plus 1 over V. But before we go on, we need to observe very well. This is a converging lens. All right, converging lens is also known as a convex lens, and convex lens usually have positive focal length. So F will be 20. All right, we are looking for object distance. Now the image distance, was it given to us? You can see it here. V is equal to 4U. Image distance is going to be negative. This is a case where we'll have image distance to be negative. All right, so we're going to have minus V. So now using our equation, we're going to have 1 over focal length is given to us to be 20 equals 1 over U is what we are looking for. We have plus minus because our image distance is negative minus 1 over V. V is the image distance, which is 4U. So, all right, so we have minus, we have minus 4U. So if we simplify this, we have 1 over 20 equals LCM here is 4U. So we have 4U divided by U. That will give us 4 minus 4U divided by 4U. That will give us 1. 1 times 1, we have 1. The same thing here, 4U divided by U. That's 4. 4 times 1, we have 1. So we are going to have 1 over 20 equals 4 minus 1, which is 3 all over 4U. If we cross multiply, we are going to have 4U times 1, which is 4U, equals 20 times 3, which is 60. So to get U, divide both sides by 4. We have U equals 60 all over 4, which is 15 cm. So this is the object distance, option D. Alright, so with this, we've come to the end of this video. Please make sure to subscribe to this channel and like, drop a comment if you have any question, and also share this video with your friends and your colleagues.